right, welcome to the next lesson. We're going to talk about congruent triangles today. This is a really key concept, useful concept in proofs that are coming up in the future, and also just for recognizing how to know whether two triangles are congruent. So this is a really packed lesson. It's got some super good information in it, so it should be good. First off, we want to fill in some blanks in our notes here. If we were to define congruent triangles, they are triangles with the same angle measures and side lengths. So we could say, like, if we've got a triangle here, well, let me draw one that's maybe a little bit more interesting. Say that this side is 4, this side is 5, and that side is, I'm just going to make up some number like 7. That would work over there. We'll say that this angle is 100 degrees, this one is 20 degrees, and that one, let's see, we got to do some math here, 60 degrees, right? And then I had a second triangle over here. Going to try and draw it the same. If it had these traits, so the picture is inaccurate, but hopefully we get the idea. These two triangles have the same side lengths, 4, 5, and 7, and they have the same angle measures, 60, 100, and 20 degrees, right? So these are two congruent triangles. They have to have all the parts that are the same. This means that all the corresponding parts, that means all of the angles and all of the sides, are a perfect match, are congruent. So the 60 and 60 go together, the 20 and 20 go together, 100, 100, 4, 4, 7, 7, 5, 5. Seems kind of silly for a minute, but it'll make more sense, the importance of this later on. So when we have two triangles that are congruent, we can write a congruency statement. And it's critical the order that you write these in. So the first triangle, it doesn't really matter. You could call it, if we were using this one, you could call it ABC, BAC, CBA, CAB, whatever you want, right? You choose that. But once that order has been determined, when you're writing your congruency statement, you need to make sure that the first letter, so like they chose to start with A, they need to make sure that the first letter in the other triangle that they use is the angle that corresponds with A. See how those two are congruent? So they had to start with D. And then the next angle was B with the two congruent marks, so then they have to go next with E. And then we could also say that the length, excuse me, from A to B, and see how that's the first two letters that are written, has to be the same length as DE. So even though it's a really small statement like that, it's super powerful. We can make, just from this statement right here, we can make 6 congruency statements. You could write this with me or don't have to, it's your call, so just go ahead and watch or write it. We know that angle A is congruent to angle D, right? The first letter listed in both cases. We know that angle B is congruent to angle E, and you probably know where I'm going next. Angle C is congruent to angle F. I don't even need to look at an actual diagram of triangles. Just based on this statement, the way that it's written, that tells me that these have parts that are corresponding to each other, that are congruent. We can also talk about the segments, right? I can say segment AB is congruent to segment DE. Those are the first two letters listed in each of them. Okay, so I'm just using those two things right there. I could say then that segment BC is congruent to segment EF. That's the next two letters in each of them. There's a sixth statement. Can you guess what that one would be? It's where we use the first and last letters, right? So AC would be congruent to DF. Okay, so we have all 6 of these relationships that can be derived from that congruency statement. So it's pretty cool. A valid congruency statement must match all the corresponding angles and sides. So once you choose the order of your first triangle, when you're listing the second triangle, it has to be in the correct order. It has to show the matching parts together. Okay, then we're going to come across this CPCTC, which is actually, it's going to become quite a good friend of ours, but it seems like a lot at first. It stands for corresponding parts of congruent triangles are congruent. And what that is saying is that if you have congruent triangles like this, then we know all 6 of these things are true. And it is such a common phrase in mathematics that it's generally understood that this abbreviation knows that it's talking about that. Corresponding parts of congruent triangles are congruent. If we were together in class, you would be hearing this phrase quite a bit. Corresponding parts of congruent triangles are congruent. You would get to know it so well that it just sort of roll off the tongue, but CPCTC is a fast way for us to write it if we're ever coming across that. So it's something we'll get more familiar with. If we know that 2 triangles are congruent, then we know that every pair of corresponding parts is also congruent. Okay, so this is just sort of restating this. If you've got that statement to begin with, you know all 6 of those things are true. Okay, let's see what we can use with this. Here they want us to list all congruent angles and sides. And I just did this up above, but maybe you could race me and see if you get them all listed here before I do. Remember that the order of the letters matters. So as I'm naming the angles, it has to be the first letter goes with the first letter, middle letter goes with the middle letter, etc. When I'm naming the side lengths, if I've got the first 2 letters, I got to use the first 2 letters of the other one. Second 2 letters and second 2 letters. And lastly, it's the first and third. Did you beat me? Probably. I was talking while I was doing it too, huh? Write another valid congruency statement. Okay, so we've got these 6 up here. What I'm going to do is rewrite this, but I'm just going to change it up a little bit. I'm going to write the first one as triangle KLJ. If I had it written like this, and all 6 of these statements are still true, how would I write the second triangle in this case? Well, K and Q go together, right? So now if I'm writing K first, I would need to write Q first. Does that make sense? And then L goes with R. Those were the last letters listed up above. And then J goes with P. So if you're looking at an answer key and you wrote an answer like this, but I've written the answer like that, we're both correct, right? You can just make sure that the letters are showing up in the same spots. Same letters, same spots, and then we're all in good shape. I hope that makes sense. If not, we can seek clarification there. But okay, now part of the assignments that you're going to have is to, given this statement, complete the following statements. And I don't even need these triangles really. They're not necessary. I'm just going to use this statement right here. I'm trusting that they gave it to me in the correct way. So they start with K and M, the first and last letters. So I know that's congruent to A and C, first and last letters over here. PK is congruent to YA. You may want to pause the video for a second and see if you can fill the rest of these in without me. Or if you want to erase me, you can. And YAC, that's going to be triangle PKM. Hope it makes sense a little bit that we're matching the order of the letters. So they gave us something from the triangle on the left or the right, and then we gave the matching part from the other side of the statement. Okay, cool beans. By the way, I have a sister who goes, that's her nickname, Sia, short for Cynthia. Okay. Now, Now, example 3, we have two triangles, and I'm going to go ahead and just draw a picture. And it may not be a very accurate picture, but that's less important. The more important thing is that I just put the matching parts together. Okay, so I've got this situated in such a way that those two should be congruent, these should be congruent, those should be congruent, and the angles should all be in the same orientation. Okay, so DE is 18, EF is 23, DF is 9x minus 23. JL is 7x minus 11, and JK is 3y minus 21. And they want us to find the values of x and y. Okay, just for kicks, and they didn't ask us to, but do you know the length of KL? It's 23 as well, right? Okay, so let's maybe solve for y first. We can set this expression equal to that one, because based on this statement, DE and JK are congruent. So we can say, okay, 18 equals 3y minus 21. And I've already solved these, so I don't have to take our time doing this. It ends up being y equals 13. I think you guys can handle the algebra easily without me. And then these two, right, DF, JL, they're congruent to each other, so we can do 9x minus 23 equals 7x minus 11, and we can solve for x, which ends up being 6. Okay, so not too bad. All right, this next piece, in years past, I've done like an entire lesson just on proving one of these things, and here we're just handing them all to you. So it's not my favorite method in the world, but given our situation, this is what we're going to do. So I may try to find a video of somebody describing why these things are like they are, but essentially what we're going to do is say, okay, we know that if two triangles are congruent, that they have these 6 statements that we can use as a result. Wouldn't it be unfortunate if, when we want to prove that two triangles are congruent, we had to prove all 6 of those things first before we could say, yep, the two triangles are congruent? Like, that would be a lot. It would be exhausting. So we actually have some shortcuts. That's what these are. So these are ways that you can prove two triangles are congruent. If they have sides that are congruent, if you know that both triangles have a length of 5, 7, 8, right, then they have to be congruent. The angles would have to be built in such a way or formed in such a way that they would be a perfect match. Okay, so that's one of them. Then we have side, angle, side. And the order of these letters matters. Okay, so the angle that they're talking about has to be between the two sides that we know are congruent. Okay, so we can head from either direction and we get side, angle, side. Then we have angle, side, angle. And this one, the side that is a match has to be between the two angles that are a match. So like that would be, if we could prove that that much is congruent in these two triangles, then we could prove that the triangles were congruent, right? So we're looking for sort of shortcuts to prove triangle congruency. The other one is angle, angle, side. Now this one, the order matters, that the side we're talking about is not the side between the two or the included side. We've got the two angles and a side opposite them, or a side after that. Okay, they both work, but then they're no thing. I do want to point out, and it's going to seem silly, so part of me is glad that we're not meeting together as a class to discuss this, but angle, side, side, which if we shortened it, of course, that would be a little swear word, right? Angle, side, side is not enough to prove or triangle congruency. So that's sort of like a way that you can alert yourself if you're tempted to write angle side side, like just because, I don't know, for me, since I know that it matches with a word that we don't typically use in school language, then I know that that's, like one of them that doesn't work. Okay. But when you're dealing with a right triangle, there's something that sort of feels like that. So notice that there's only 2 letters here. And one of the letters, H, only shows up when you have a right triangle. A hypotenuse only exists when you have a right triangle, okay? So it sort of is going to feel like there's the hypotenuse, the one that's opposite the right angle. So if they told us that these 2 hypotenuses were a match, were congruent, I should say, excuse me, I want to erase that and get there. And they told us that one of the legs was congruent. So they said, okay, this one is as well. Notice that it kind of looks like angle side side, right? And so if you come across angle side side and hang on, that doesn't work. The only case where it does work is if you've got a right triangle, and in that case it's called hypotenuse leg. And I like it for a couple of reasons. 2 letters instead of 3, so a little bit faster to write, but also it's super descriptive. It's telling us a lot more about the triangles when you're using hypotenuse and leg, that we've got to have a right triangle. So anyway, these are the 5 things that we're going to use that are super handy to us. So this is a note page that's worth hanging on to. Like if you get a chance to print an extra one or take an extra picture or something, this is something we're going to be using for the next little while. So key piece of data that's worth hanging on to. Okay. We also have some reasons for why we might say sides are congruent. So this is like, these are preps as we're coming up with writing proofs about why might we say that we were able to make that justification. So you could say that sides are congruent if they give you that information. That's easy. If they tell you that something is a midpoint or it's bisecting something, then we know we've got some congruent sides, so that could be useful for us. And then our friend reflexive property. I had forgotten that this gets used so much in this case. So sometimes we're going to have, let's see, 2 triangles that say they share this side, right? Well, as you're proving side angle side or side 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 or whatever, we want to be able to say in our proof, well, this side is equal to itself, right? You'd say like AB is congruent to AB. Well, that's our friend, the reflexive property. That's sort of duh, like obviously they're equal to each other. So that's going to be one that shows up quite a bit. And then here's some reasons we might use for why we have congruent angles. Again, it's given, that's handy. Vertical angles, that's our friend, right? They're across from each other and so they're congruent. We also have these 3 that we were focusing on in the last lesson, right? So these are congruent only if the lines are parallel. So suppose that you've got some parallel lines like this, right? And then we could say that these 2 are alternate interior angles, right? These 2 are alternate exterior angles. And then we could also say that we have some corresponding angles. And I'm going to go ahead and change color on this one. We could say like these 2 are corresponding. So alternate is telling us they're on different sides of the transversal. Interior versus exterior, I hope that that's sort of obvious. Inside between the 2 parallel lines or outside between the 2 parallel lines. And then corresponding is on the same side of the transversal. So see how the x's are both on the right and on the same side below. So when we were trying to come up with a definition as a class, remember that we said same side for corresponding. So they're on the right of the transversal or the left or whatever, and then below the lines or above the lines, whatever it needs to be. Okay, then we have an angle bisector. Remember that a bisector cuts two things exactly in half. So if they tell us that we have a bisector, we definitely want to use that information and say that we've got two angles that are congruent as a result. Okay, these are a lot of practice problems, and I don't think we need all of them, but some practice is important here. So I don't know, I'll just run through, and then if you feel like you got it and want to stop the video, feel free, okay? So first off, for each pair of triangles, tell A, are they congruent? If yes, write the congruency statement. And then give the postulate and theorem that makes them congruent. Okay, so I'm going to give a little bit more than that. So I'm looking at a couple triangles here to try to decide, do I have some congruent triangles? And I think that, based on some of the proofs I had before, let me see, maybe highlighting would be useful here. We have those sides that are congruent, right? And then we have some angles that are congruent. And if we're talking about this triangle and this triangle, they also share a side. Okay, so I'm going to say yes, we have some congruent triangles here, and I'm going to write the reason why right now. Side, angle, side. The angle comes between the two sides where they meet, right? Okay. We were able to use that. First, they gave us one of the sides. They gave us the angles, but then the other side, we had to use the reflexive property there because it was itself, right? So if I were writing a proof, I could give that in there. And then we have to write the congruency statement. So take one of the triangles, and however you want to switch those letters, move those letters, it doesn't matter. So if we called one of them, say we did J, K, M, that's sort of alphabetical order for those three letters anyway. If I were making a congruency statement, so now I have to match the correct parts with the other one. What's the angle that goes with J? It's L. Now, I'm looking at this triangle now, okay, to see how does it match up with that yellow one. So J and L were in the right spots. But now, do you know what's going to come next? It's going to be M and then K. Right? That's the order that would make these two triangles seem exactly the same. If you could think of sort of taking this triangle and like flip it so that it lined up exactly with this one, then we're looking for which letters would go together. It's kind of tricky, so if you need to pause for a second and see if you can figure that out, feel free to do that. Let's move on to the next one, and maybe it'll make sense there too. Okay, so first off, we have ourselves two right triangles. Did they tell us, let's see, right triangle, right triangle. Did they tell us the hypotenuses were the same? They did not. So hypotenuse leg isn't going to work in this case, but we do have side that's the same. We have a matching angle, and we have this shared side, right? So I'm going to say yes, these are congruent using side, angle, side again. And once more, we used the reflexive property because they share that side. It is itself. Okay, as you name this triangle, I'm going to name the first one ABC, alphabetical order. On the other triangle, what angle matches up with A? And then which one matches where the B is for this triangle? So if I highlight the green triangle, the B is up there, but on the blue triangle, where is the matching spot on that one? It's not B where the 90-degree angle is it? That's down at C. So does that help a little bit? It's as though we took this one and rotate it around so that it's a perfect match for that, and then just kind of see where do those letters line up. Okay. E is the midpoint. Because it's the midpoint of AB, then we know that those two lengths are congruent. Midpoint is the middle of those lengths. Oh, and it's the midpoint of CD, so we know that those two lengths are equal to each other as well. And we have some vertical angles here, right? So I'm going to say yes, these are congruent also by side angle side. I promise there are others, they're not always side angle side. So what rules did we use? We had definition of midpoint, and we also used vertical angles, right? If we were writing a proof, we could use that information there. Okay, so naming the triangles again. This is kind of the tricky part, but pay close attention. It's important. If we did ACE on the left, maybe pause and see what you would write for the congruency statement on the other side. BDE, right? And you can check the parts, like we're saying that AE is congruent to BE. That's a match, right? And that CE, last two letters, is congruent to DE. And they both have the angle E in the same spot, showing up last. So hopefully it's starting to make some sense. This one is going to be yes for side, 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 because they have that side in common, reflexive, right? Our congruency statement, if I said ACD, and if you start to write it and you're not happy with it, like ADC seems like an easier way to go. Because then I could say the length AD goes with CB. So what if it, suppose I didn't change it. If it had been ACD, that would go with triangle CAB. Right, so it still works, just whichever one you like. All right, this video seems super long, so I apologize for that. Okay, this one we have two sides that are given. So we have side, side. The other side I don't think we have, but do we have the angles in between? Now, because they've said that these segments are parallel and we have this transversal, then we have some corresponding angles there. So we can say yes, through side angle side, we had some corresponding angles. Okay, if we did this one should be kind of easy, I hope. They have sort of the same orientation, so that helps, right? The corresponding parts are in similar places. Well, that makes it a little bit easier to see. Okay, here we've got two sides that are congruent. We do have some vertical angles, but that would be angle side side, which is a no-no. We don't have that, remember? So is there another angle we could get? And because they are telling us that these lines are parallel, then we could use alternate interior angles. So then we would have side angle side. Okay, I hate that I'm not getting feedback from your faces to know if this is making sense or not making sense. So you'll have to let me know if it's confusing to you and doesn't really just seem to make sense. I could do another video maybe breaking this down a little bit more. Okay. Oh, they didn't number any of these. This is example 4 and it just goes and goes. Okay, last couple. This one we've got angle, side, side, right? It's not side, angle, side because they didn't give us the angle that's between the two matching sides. So this is a no. There is no congruency there. I was thinking I had another no. Did I mess up? Oh. Oh, it's on the next page. Sorry. Bye. Nope. That's it. That's the only one. Okay. So angle, side, side is no good. Doesn't work. If we had a right angle and they gave us the hypotenuse, then we could use hypotenuse leg, but that's the only one. Okay. FH bisects angle EHG. So angle EHG is bisected, so we've got that and that. They're congruent, and it bisects EFG, this angle up there. So those two are congruent as well. So I think we have enough for angle, side, angle because they share that side. It has to be a match to itself. Reflexive. Sorry, yes, goes in that spot. Okay, so if we name the triangle on the left EFH, this one I think you could do. What is its congruency statement? GFH. Oh my goodness, not letting me write. Okay, we got it. All right, so this was some good stuff. Got a couple of pages. You can see that second page looks a lot like this. Please let me know if you're having any problems turning things in or anything like that. Okay, see you later.